Math 1332, Chapter 11, Statistics, Section 3, Measures of Average, Video 1, Mean of a Data Set. Most of you already know how to do this, more than likely, because the word mean in this context has the same meaning of what you think of as average. So if I said average some numbers, I bet you know how to do it. Mean is pretty much the same thing, again, in this context. There are different types of means, but for our purposes, we'll just assume one type of mean. Let's get past the formulas and stuff. Let S equals x1, comma, x2, comma, x3, comma, all the way to some last number, which we're calling xn, be a set of numerical data. It's important to make note that this is numerical data because we're about to do number things to it, such as add and divide. The mean of S, denoted by x bar, that's how you read that symbol. It's literally an X with a bar over it, is the sum of the values divided by the number of values. In other words, you add up all the numbers in the data set and then you divide by how many numbers that was. Well, most of you know this is the average. If you have 4 grades and you want your average, you add them up and divide by 4. That's all this is. Mean, in this context, is just what you know as average. Find the sum and divide. Now, there is a shorter way to write the formula using the Greek letter sigma. Sigma looks like a capital M knocked on its side, but it's a Greek letter, and you may have seen it in a math class before, but it's a mathematical operator that indicates to take the sum of a set of values. So if you ever see a sigma in front of something, it means take the sum of all these things. Using this, we can write the formula for the mean of a data set as x bar equals sigma x over n. Again, that sigma x simply means take all of your x's and add them. In other words, it's a shorthand way of writing this. But regardless of the formula in which version of it we write, you all know how to take an average. You're in college, you've averaged numbers before. So let's take a look at a couple of examples. It's really the same example twice, once and then once again with a twist to make a point about calculating means and interpreting them. For example, calculate the mean annual salary for the following employees. Sheldon, $58,000. Leonard, $65,000. Howard, $944,000. Rajesh, $20,000. Amy, $52,000. Penny, $51,000. Bernadette, $53,000. Stuart, $55,000. Bert, $50,000. And please don't anybody try to make something about which name has what amount of money. The names were just listed randomly and the numbers were borrowed from an example I saw. So how do we find the mean annual salary? Again, in this context, the word mean just means average. Well, first we have to know how many values there are. That's not the first thing we need to know, but we need to know how many there are. That's supposed to be a check mark. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 values. That means we're going to end up dividing by 9. But what are we going to divide by 9? This sum, which I'll write sigma x. Again, that just means take the sum of all those numbers. Well, adding those numbers is straightforward. It's just calculator work. I'm not going to waste your time on the video doing that. I'll just pause it and find the sum. The sum of all 9 salaries is $1,348,000, which means the average, or excuse me, the mean, x bar, is equal to 1,348,000 divided by 9. This will probably come out to be a decimal. And although we weren't told how to round this because it's a dollar amount, it would make sense to round it to 2 decimal places. And if we divide by 9 to the nearest cent, we get $149,777.78. It's actually 0.7 repeating, but that third 7 would round the second 7 up to an 8. And that's all you have to do to calculate the mean. Take the sum, divide by how many values you added. But do you see a problem with this, saying that the average salary is $149,777.78? Let's say this company is recruiting, and one of the recruiting points that they make is our average salary is almost $150,000 per year. Come work for us. You see a problem with saying that? It's not wrong, but it's a tad misleading, because look at all 9 salaries. How many of them are below average? All except Howard. And this points out a problem with taking the mean, or the average, if you will, is that sometimes the value that you get for the mean can mislead you into thinking, oh, on average, this is what everybody gets, which is not technically wrong, but it is a tad misleading. Why do you think this happened? Why do you think that the average for these values, the mean for these values, is greater than all but one of them? Well, look at Howard's salary, $944,000 per year. That is more than 10 times anybody else's salary, even greater than that. It looks like it's more than 16 times anybody's salary, maybe even a bigger multiplier than that. Oops, I didn't look at Leonard's. That's more than 10 times everybody else's salary. If you were to put these numbers on a number line, we'll take that as a number line. If you were to put these numbers on a number line, the lowest one would be down here, 20,000. Let's say Leonard is here at 65,000. Everybody else would be in between, and Howard would be way over here somewhere with his 944,000. When you have a value that is significantly larger than the rest or significantly less than the rest, that value is called an outlier. I'm about to type that or write that word. That value is called an outlier, O-U-T-L-I-E-R. And there is a formula for setting up a boundary beyond which you're considered an outlier. But in this set of 9 salaries, I think it's pretty obvious that Howard's salary is significantly larger than the rest. And that's the problem with means. They are heavily influenced by outliers. To make the point, let's calculate the mean salary again, but this time we're going to exclude the outlier, Howard. So we'll cross him out for a moment. Maybe he's the CEO and everybody works for him. If we were to omit Howard, how would we calculate the mean now? Well, there used to be 9, so there should be 8 now. 1, 2, 3, 4, 5, 6, 7, 8. There are. So n equals 8. What's the sum now? Well, all I have to do is take the previous sum and subtract 944,000 to give 404,000. If we get rid of Howard's salary in this calculation. And notice that Howard makes twice as much as everybody else combined. Interesting. Without the outlier, the mean salary would be 404,000 divided by 8, which is exactly 50,500. Does that seem like a more reasonable mean salary for the employees at this company? Well, with the exception of Howard, yes. How many of those remaining 8 salaries are greater than 50,500? This one, and all of these. And there are 2 that are less than. At this point, you could even argue that among these 8, Leonard is an outlier, but he's not really that much higher than Sheldon. But we're not going to argue what constitutes an outlier. Let's just say that compared to everybody else, Howard's salary clearly is. But this points out a flaw with using the average or using the mean to come up with a measure of average for a data set. The mean of a data set is heavily influenced by outliers. A single relatively large or small value can result in a misleading mean, not an incorrect mean, but a misleading mean. I refer you to slides ago where the mean was almost 150,000, but nobody was near making that except Howard, who was way above it. For this reason, sometimes the largest and smallest values of a data set are omitted prior to calculating the mean as to avoid the unintended effects of outliers. This practice isn't always done, but if you ever, like I remember, and I don't know if they still do this, but at the ice skating in the Olympics, they had all the different countries' scores, but then they would throw out the highest score and the lowest score and then average the rest. I don't know if that's still how they do that. Part of the reason they did that was to try to mitigate the effect of a bias. Oh, I'm from this country, I'm gonna unintentionally score them higher, or my country's at war with that country, I'm gonna unintentionally score them lower. But if you ever see somebody throw out a high or low value, that's usually the reason why, because outliers can heavily influence a mean.